All right, here are the answers. Here are the answers to chapter 5 in the review packet for your exam. Okay, and we're gonna go fast because we only have an hour to go through a lot of stuff. So, for question 1, A and B, you have to write these in standard form. And hope you can see both answers. Here's, actually I'll put one at a time.
Is this all on YouTube? Yeah.
It's, I'm YouTubing it now.
Yeah, I think it's on.
Okay, yeah, this is on YouTube from, if you have to go back to chapter 5 though. What you're gonna do is distribute, clean it up, and standard form is highest degree then lowest. Now, the name of it, you're gonna look at the degree. This is a cubic function. If there's only one term, it's a monomial. If there's 2 terms, it's a binomial. If there's 3 terms, it's a trinomial. After that, you're just gonna call it polynomial with how many terms. So I would call the first one, it's a cubic function with, a cubic polynomial with 4 terms. And you gotta know the left and right behavior. This is an odd degree power. So, and the leading coefficient's negative, so the left is gonna be going up.
You messed up.
I did.
Yeah, I was
Oh, no, yeah, this is,
right with
this
you.
should be the other, sorry. It looks, this is gonna look like this. Because the leading coefficient's negative. So we would say the left is going up and the right is going down. If it were the other way, if this were a positive 6, it would look the other way. The right side go up, left side go down. Now the maximum turns, you go 1 degree less than the power here, so it's a 2. And you can't have, name all the even numbers less than 2. You're not gonna say 0, because you have to have some terms. For B, you do the same thing, simplify this. And I got 10x to the 4th minus 15x cubed plus 34x squared minus 16x. This is a quartic polynomial with 4 terms. Okay, any questions? And because the degree's even and the leading coefficient's positive, both left and right are going up. The maximum turns is 3, 1 degree less, and since we can fit another odd number less than, greater than 0, it's 1, 3 or 1. For 2A and B, if you have a table of values and you're trying to figure out if what is the degree of the polynomial, you look at the common differences. This one has 2 sets, the second set is common, so this is a quadratic. And I am also going to copy this whole document, this answer sheet, and I'm posting it on Weebly. So if you have access to Weebly, or our computer, if you go on to msaudio.weebly.com, or the directions are going to be YouTube, but that you can get print yourself a hard copy of what I have here. Okay, I'm going to scan it and I'll put it on Weebly. For B, we had 3 sets of common. We had the 3rd set was common, so it's a cubic. Questions on how to do that? You're not, I don't know if you'll have time to write everything down that I have.
That's what
Okay. For 3, you're asked to factor each polynomial and state the zeros and the multiplicity. So for A, I pulled out an x squared, and then I said, oh, that's x minus 3 quantity squared. So my 2 zeros are 0 and 3. And their multiplicities are both even. So I know that it's gonna touch at both of these spots on the x-axis at 0 and 3. Does this come back? You guys getting this?
Yeah.
Okay. Then for B, you're gonna pull out 3x cubed, and what's left is 3x squared minus x minus 10. And then I factored this was factorable. So my 3 zeros are 0, -5/3, and 2. All of these zeros have an odd multiplicity, so it's gonna cross through at all 3 spots. Number 4. You're given the zeros, and you're told it's a fifth, quintic means 5th degree. So I have to have 5, the power is 5 on this. And it says that x is 0, one of the zeros it occurs 3 times. So how do you write your polynomial? This is an easy problem. X cubed, and then remember it's the opposites of these. Now on your test, you're gonna see x plus 5, x minus 4, and x cubed. And it's gonna confuse you because you gotta know that these zeros are the opposites here. So be careful on that. Remember, you can use an index card. For B, it's a cubic one, and your zeros are at 3, so x minus 3, x plus 2, and x minus 1. For 5, you had 6 polynomials to factor. What you're gonna do is, for this one, A, I pulled an x out and then factored this. X plus 10, x minus 2, your zeros are 0, -10, and 2. Remember, see this number right here? That's the maximum number of zeros you're gonna have. So there's 3. For B, B is that lovely, the sum of 2 perfect cubes. And I broke it up here for you. So you gotta remember how to factor this. It's one of each of these with whatever sign that is. Then you have 3 times 3 is 9x squared. You switch signs, multiply one of each of these, so minus 6x, and then this sign is always a plus sign, and 2 times 2 is 4. Now, one of your answers is -2/3. The other 2, you have to use the quadratic formula. So I did opposite of B, plus or minus, b squared minus 4 times a times c, and I hope I did my math right, but this is what I got. I got 1 plus or minus I, the 6 canceled, 6, 6, and 6 here. So it's 1 plus or minus I root 6 over 3. Now, if the directions say find all real zeros, the only real zero is -2/3. These two are imaginary because you have a negative under the radical. So read the directions. If it says find all zeros, then these are all of them. These are the 3. But real is just this one. All are these both. For C, what I did was I got everything to one side, and I did grouping on this one. I took out x squared here, and I was left with 2x minus 1. And then I took out a -4 and left with 2x minus 1. So I pulled out the 2x minus 1, and I'm left with x squared minus 4. But this, you can set this equal to 0, and you do your, take the square root of both sides, you get plus or minus 2. This is 1/2. So you have 3 zeros here, and these are the 3, and these are all real. So there's 1/2 and plus or minus 2. For D, this one, I got everything to one side, and I first saw an x I took out, and then I have 20x plus 7x minus 3, and I didn't feel like trying to see if this would factor, so I just went right into the quadratic formula. So hopefully I did it right, -7 plus or minus b squared minus 4 times a times c. And these two negatives cancel out, so you have 240 plus 49 is, oh, I do have a mistake. 49 is gonna be plus, this should be 289. Right? So, do we know what the square root of 289 is?
Yeah, that's a perfect
17.
one.
It's negative 7 plus or minus 17 over 40. Now, can you do anything with that? Yeah, you can. You can do. I am all over the page. So you can simplify this more. So negative 7 plus 17 is 10 over 40, which is 1/4. And we have also negative 24 over 40, and we could divide each by 4, and another 2, negative 3/5. So negative 3/5 and 1/4 are 2 more zeros. How about that? So the 3 zeros for 20, you're gonna see it down this page, is 0, 1/4, and negative 3/5. So I had a little mistake here, 49 and 240 is 289.
How did you get those numbers?
These two right here, well, 49 and 240 is 289, and the square root of 289 is 17. So you have negative 7 plus 17, which is 10, over 40, 1/4. And negative 7 minus 17 is negative 24 over 40. I divided them both by 4, and I got negative 6. So I simplified, reduced this twice. Okay? Letter E, I brought 36 over, and I did the difference of 2 perfect squares, and then I set each of these equal to 0. I got 2 real and 2 imaginary zeros for this one. F is factorable. F is factorable. It's x squared minus 8, x squared plus 6. So you set each of these equal to 0. This is the same. You have x squared minus, if you set this equal to 0, x squared equals negative 6 square root both sides, and you get plus or minus root 6i, and then this one, plus or minus 2 root 2. So you have 2 real and 2 imaginary for this one. For 6, we're gonna perform long division. We can't do synthetic on this. So the divisor is 3x squared minus x plus 5, outside, inside. Now how do you do synthetic division? Make sure you don't have any holes here, which you're fine. So now you want to get rid of 12x cubed. So 4x times 3x squared is 12x cubed. So when you subtract, you'll get rid of that. So you just keep multiplying. You have to distribute 4x times all 3 of these. Subtract, and you get negative 6x. Now remember, these are going to cancel. So it's negative 10x squared plus 4x squared, which is negative 6x squared. And then subtract, you get 2, and then bring this down. And now negative 2 times 3x squared is negative 6x squared. You want these to cancel. These are going to cancel. It's going to turn into a positive 10. And negative 5 plus 10 is negative 15 plus 10 is negative 5. That's your remainder. So the answer to this is 4x minus 2 with a remainder of negative 5. Questions on that? Number 7, you do synthetic division. You take the opposite of this number, put it outside, make sure you have no holes. There is a hole right there at x to the first power. Bring this down, multiply, add, multiply, and add. You get 3x squared plus 1x plus 5. And then what you want to do is, if they ask you to solve this, you would set this equal to 0, but they just want you to divide. That's the answer. That is the answer right there. Number 8, use synthetic division. You're going to put a -4 out here. And 1, -3, 5, -7, and 2. Bring down the 1, multiply, add. Multiply, add, multiply, add, multiply, and then add. That is your remainder, 558. Number 9, find all the possible zeros. You take factors of your constant, which these are all the factors of the constant. All the numbers that go into 12, 1, 2, 3, 4, 6, and 12, over factors of the leading coefficient 1, 2, and 4. So making combinations, if I had to sit there and list all these, you'd have 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. You keep doing that with all these. You're even going to have fractions like 3 halves, 2 fourths. Okay? Number 10. Find all the roots. So what you're going to do now with this possible zeros, and I just went right to the answer. You take possible zeros and you're going to have to, one by one, test these numbers out to see where you get a 0 using synthetic division. So I did -1. The reason I knew 1 wasn't going to work was because these are all positive. 1 would be an upper bound. It's too big. Because if I had a 1 out here, all of these would be positive, and that's too big of a number. So I went the other way to the negative. So I started with -1, that's my logic, and you get a 0. So if 1 is a 0, now what we have here is this trinomial, 1x squared plus 2x plus 4. And now what you have to do is solve for these two. And I show you here that I used completing the square. I subtracted 4, took half of 2, squared it, and finished the rest. The answer is -1 plus or minus 3 root 3i. And also don't forget -1. For B, I tried -1 and it worked. -1 works. So 8x squared minus 6x plus 1 was left. And then what I did was the quadratic formula to figure out the other two. So opposite of b plus or minus b squared minus 4 times a times c. So this is 32. You get 4 underneath here. Square root of 4 is 2. So it's 6 plus 2 over 16. So that's 8 over 16, which is a half. And 6 minus 2, which is 4, over 16, which is 1/4. So there's 3 zeros on this one. -1, 1/2, and 1/4. Do you remember 11, when we talked about irrational and imaginary zeros? They came in what? Pairs. So the other two would be 4 minus root 7 and -6i. Number 12. Okay, if I give you -4, they want you to write a polynomial. So if 4 is a 0, so is -4. Or, I'm sorry, if -4 is a 0, you write x plus 4. If 2i is a 0, you're going to write -2i and plus 2i. And then what you have to do is factor this out. X times x is x squared. The next two cancel, and then -2i, this is what you have here. X minus 2i times x plus 2i. So if you factor this out, you get x squared, the next two cancel out, and then you get minus 4i squared, and I squared is -1, so this goes to plus 4. So that's how I got that. Same with B. If root 5 is a 0, so is negative root 5. So you'll FOIL this out, and if negative 3i is a 0, so is positive 3i. So when you factor this out, you get x squared plus 5, and then x squared plus 9. Now, they may want you to FOIL this out more. The answer may be written as x to the 4th, and then you have plus 9x to the 2nd, plus 5x to the 2nd, plus 45. And you can make one more change and add these two up. So that's your polynomial that has these two zeros, and it also has two more. Questions? I'm only gonna do 13 because it's the same as, 13 A and B. 14 is pretty much the same. This is the same as what we've done, find all the zeros, they want them all. So you're gonna do your rational zero test. I just wanna let you know, negative 3 works. 3 worked. And then you end up with this quadratic, 2x squared plus 3x plus 1. And then what you have to do is the quadratic formula to find the other two zeros. And I got negative 1/2 and negative 1. There were a lot on this review packet of that section. In B, 3 works. And then you end up with 1x squared minus x plus 1, and you have to use, now these are imaginary zeros that were left. So the 3 answers for B are 3 and 1 plus or minus root 3i over 2. So there's 3 zeros. Here's your answers right there. And for 13, the 4 answers are, I'm gonna go back for A. The 4 answers are negative 3, 3, negative 1/2, and negative 1. Questions? Okay, now we're on chapter 6. What's the square root of 0.01? It's plus or minus 0.1. The cube, remember, you can't take the square root of negative numbers, but you can take the cube roots. The cube root of negative 343 is negative 7. Number 3, no solution. Can't take an even root of a negative number. For 4, you're looking for A, you're looking for 4 of a kind. What I have here on the side here, I took the number 512 and I broke it down. 2 goes into it, 256, 128, 264, then 8 times 8, and 8 times 8 is 6 2s. So how many 2s do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. So how many groups we have, you're going to take out? If you have 9, this is what you need to see. There's 9. You're looking for 4 of a kind. So there's one set, and there's another set. So 2 times 2, that's where the 4 comes from. The 2 stays. And now you have 7 x's. So you're going to take one group of the x's out, but 3 x's stay, and then 2 groups of y's come out, 1 y stays. For B, you can take the cube root of all three of these. The cube root of 64 is 4. The cube root, you've got 3 sets of, you've got 9 y's, 9 x's. 3 sets come out. And the cube root of 343 is 7. For multiplying, you can take from the other one to make a set. So roots, you have root 3x, and you have root 6. You have 2 times 3. 2 times 3, x, x, x. So you're looking for 2 of a kind. Here's 2 3s. And then you have two sets of x's, so 3x squared root x. That stays. So that's your answer. Same with b. You want to break these numbers up. I got 5z squared y. Actually, y should come first. It should be 5y z squared, and then times the cube root of x squared. Questions? For number 6, if you're dividing and radicals are the same, you can simplify. You can take this 2 out of this 8, and you get square root of y over 4, root 4x cubed. Well, the square root of 4 is 2, and you can take out an x here, you're left with root x. But now you've got a that's what you have. Then you want to rationalize the denominator, multiply both by root x to get rid of that radical. So your answer is going to be root xy over 2x squared. For b, because you're dividing and it's all underneath the cube root, you're going to cancel what you can. So 5 goes into 625 125 times, and you're going to cancel these two x's with 2 here, you get x to the 10, and these 4 with these 4 y's with 16, the 4 up here, so you get y to the 12. Now group them up, there's nothing except a 1 in the denominator, which you don't need. The cube root of 125 is 5, you've got 3 sets of x with 1 left over, and 4 complete sets of y's. Number 7, if the radical and the index is the same, you just combine like terms. So 14x minus 8x is 6x root 2. For b, you have to simplify this. So you have to figure out what, simplify square root of 128 and 50 and 72. That's what you get. And then combine like terms. For 8, you're going to FOIL. 4 times 4 is 16. The next two cancel out because it's plus or minus root 5. And then root 5 times root 5 is minus 5. 16 minus 5 is 11. For b, you're going to factor 4 times 7 is 28. 4 times negative 2 root 6 is negative 8 root 6. Plus 7 root 6, and then minus 2, and then we have a pair of 6's. 6 times 2 is 12. These two are like terms. You add them, you get negative 1 root 6, and these two are alike, you get 16. 28 minus 12 is 16. C, you've got 2 minus root 7, you've got 2 of them. So you're going to FOIL this out. 2 times 2 is 4. 2 minus 2 root 7 minus 2 root 7 is minus 4 root 7, and this times this is plus 7. 7 and 4 is 11, 11 minus 4 root 7. For 9, you have to multiply by the conjugate, because you want to get rid of the radical and denominator. The conjugate is 5 plus the square root of 3. So you're going to FOIL. 7 times 5 is 35. 7 times root 3 is 7 root 3, plus 5 root 3, and then plus 3. Root 3 times root 3 is 3. And then 5 times 5 is 25, the next two cancel, and then you get minus 3. 25 minus 3 is 22. Add these up, you get 38 plus 12 root 3. Now I look at these three numbers and say, hey, I have a 2 common in all 3 spots. 2 goes into 38 19 times, 2 goes into 12 6 times, and 2 goes into 22 11 times. So that's your best reduced answer. Questions? B, a little bit more challenging. The number that you're going to multiply, the conjugate would be 6 minus 3 root 2. you're gonna FOIL, 6 times 4 is 24. 4 times negative 3 root 2 is negative 12 root 2, and then minus 18 root 2. And then this times this, you have 3 root 2 times 3 root 2. Well, 3 times 3 is 9, times 4, whoops, I've got a boo-boo.
Yeah, but
9 times 2, no, it's right, 9 times 2 is 18, that's right. It's 9 times a 2, which is 18, I have it right, negative 10 to 9, that's right. So 24 and 18, I've got 42, and these two are negative 30 root 2. And then I said, I see a 2 here, I can divide them all by 2. So when I took the 2 out of these, I got 21, 15, and 9. And then I said, oh, there's a 3 I can take out of all 3. So divide this by 3, divide this by 3, divide this by 3. I know I'm talking fast and going fast, but still I'm gonna get through this whole thing. Six, 4. Okay, how do you do these with these fractional exponents? So, you're gonna distribute 27 to the 1/3 power is just 3, guys. 27. So you should know 27 to the 1/3 power is the same as, it's the cube root of 27, which is 3. Now, what do you do with these powers? Negative 3 and 1/3, you multiply them, and you get negative 1, and then 9 times a third is 3. So now, what I see here is this has to go shift down in the denominator to get rid of a negative exponents. So the answer is 3x cubed over x. For B, we're gonna multiply 6 times 4 to get the 24, and now you've got x to the 3/4 times x to the 1/3. If bases are the same, you have to add these two exponents. So what's 3/4 and 1/3? You gotta get a common denominator. It's 13/12. See? This is a power to power problem. 1/4 of negative 8 is negative 2, and then switch it. D, power to power, you're gonna multiply 2/3 times negative 9, 3 goes into 9 3 times, so this is gonna become negative 6. And 4/3, you get 4/3 times negative 9, 3 goes into that 3 times, you get negative 12. Then flip-flop these to make a positive, and then simplify it, x to the 6th. 6/5. So for this one, I would add 15 to get 20. Get rid of this. You want to get rid of these two pieces right here. You want to get this by itself. So add 15 for 20, divide by 4, you get 5. Then you're going to cube both sides. You get 125, and then x minus 2, add to 127. For B, you would add 2 to 8, you get 10, and then square both sides. 100 here, drop the radical, subtract 4, divide by 3, 32. For C, divide by 2, you get 8. You get 9. Then you're gonna I would cube both sides first. You get 729. Then square root both sides. So x minus 1 is plus or minus 27, and then add 1. So 1 plus 27 is 28, and 1 minus 27 is negative 26. For letter D, I think there's an error on it.
I couldn't solve it.
You couldn't solve it? You couldn't solve it?
I have the same thing, but I couldn't.
Yeah,
it's just
you
not
can solve it, you just have to use the quadratic formula. If it were 30, if this were 36, If this were 36, like right here, then you can factor it. You could say -9 and negative. See, if it said x squared minus 13x plus 36, then you'd have x plus 9, I'm sorry, x minus 9. Right, because these two multiply to give you that, and then 9 and 4. But this one, you can't factor that. Okay, number 12. Everyone should be able to add these two up and put them in standard form.
7.
So 5x squared minus 7x minus 6, and the domain is all real numbers. For B, you should be able to subtract in the right order, G minus F. So you're going to distribute the negative to F, and then simplify it. So negative 5x squared plus 27x plus 18, all real numbers, is your domain. Who did C? Did you do C? Did you get? It's a really long problem. I got 50 x cubed minus 72x minus 290x minus 72.
There's error in those little portions. I got 50x cubed and I got negative 72. But
Maybe I made a mistake. Did I make a mistake? You sure it's you? That's what I got. All real numbers is your domain. And then for D, you're going to divide these. And unfortunately, that numerator, I know you hate factoring those kind, but it did factor. The denominator, you can pull a 2 out. Now, the domain is all real numbers except negative 3/5, because you set this equal to 0, and it can't be negative 3/5. For 13, how do you do these composition ones?
You're going to plug a -4 in for the f of x and then plug the answer to that into
Yep.
G.
You got it. You should get 51. You guys did very well in that section. For B, you guys struggled with this. You gotta take the G function, because it's closest, take G, and you're gonna plug it into F. So, in other words, it's 2x minus 7 squared, then you multiply that by 2, and then subtract 3. The answer I got, so I squared it first. I got 4x squared minus 28x plus 49. Then I multiplied this all by 2. And then I subtracted 3. And that's what I got for my answer. Six, 7, and 6, 8. You've got a radical. This is a rocket, you guys. This one we called the rocket. It starts at, it actually starts, if I drew my x and y axis, it starts at 5 to the right, and it looks like that. So, the domain on this function, the domain is x has to be greater than or equal to 5, and it's all, y is greater than or equal to 0. So when you do the inverse, what happens is you switch these around. X is going to be greater than or equal to 0, and y is going to be greater than or equal to 5. And then switch x and y around and resolve it for y. And since its inverse is a function, as long as you restrict the domain, you've got f negative 1x. Sorry, this is kind of messy, but you should have f negative 1x equals x squared plus 5. For B, what does this look like, you guys? X minus 3 squared. It's a parabola, and it's to the right 3. So what is this, where is it starting here? At 3. The domain for parabolas is all real numbers, and the range is, since it's shifted 3 units to the right, it's y is greater than or equal to 0. So for the inverse, you switch them around, and it's not a function when you switch them around, because it ends up being a parabola on its side. For 15, very simply, how do you find the inverse of a line? Well, for this one, I just gave you a simple y equals 1/3 x minus 4. You begin at 4, -4, and you go up 1 and over 3, up 1 and over 3. I just took these 3 points, which I listed, and I switched them. So this point is 0, -4, so I graphed 0, -4, 0. So these two are inverses, these two are inverses, and these two are inverses. Easy? And by the way, the inverse will be a function. For the next one, B, here I just made a T-chart. The vertex is 3, -1, so from there I went 2 to the left, 2 to the right of 3. And I can't, this is my original, this is this graph right here, 2 times x minus 3 squared minus 1. How, ladies and gentlemen, do I graph the inverse of this? I'm gonna take each of these points, so 1, 7, it becomes 7, 1. 1, 2, 3, 4, 5, 6, 7. 2, 1 is 1, 2. 3, 1, 3, -1 would be -1, 3. That would be the vertex now. And then we're gonna graph 1, 4. And we're gonna graph 5, 7.
7, 5.
I'm sorry, 7, 5. 1, 2, 3, 4, 5, 6, 7. Here it is. So it looks like this. And is that a function? No, it's not. For 16, it's a snake. It's a cubed problem. So what numbers can we take the cube root of? -8, -1, 0, 1, and 8. You get -2, -1, 0, 1, and 2. Now, what are you gonna do with this? If you wanna make a table, do that. This is gonna be, you could also just, if you could just transform this one, easy. You're gonna slide 4 units to the left. You're gonna flip it over the x-axis, and you're gonna be 1 unit down. How do you do it mathematically? You subtract 4 from your x's. You multiply your y's by -1, and then you add you subtract -1, and that's the graph you should get.
You add a -1.
You add -1 or subtract 1. Same thing. Add -1 or subtract 1, same thing. Okay, and B is a rocket. What points can we do square roots of? 0, 1, and 4. 0, 1, and 2 you get for y. And now, how is this transformed? You're gonna go 2 units to the left. So I wrote subtract 2 to the x. Then you multiply the y values by 3, and then you subtract 1 to the y. And these are my new points. I got -2, -1, -1, 2, and 2, 5. Last two. Hooray. For 17, you're gonna pull, and one of these is on your exam. Pull out a 4 here. 4, everyone paying attention to this, 4, take out the 4, you get x plus 4. Now, can you take the square root of 4? What do you get? 2. So this is what you're gonna graph, much easier than this. So what do? You take your table, if you were to graph it, your 0, 1, 4, you would subtract 4 from x, multiply the y's by 2, and then subtract 2 from y. These two affect the y, the inside stuff affects the x. And then the last one, I'm gonna pull out 125 from these two numbers. Can you take the cube, and there's a negative already out there, standing out there, waiting. What's the cube root of 125? 5, so it's gonna be a -5 times the cube root of x minus 2. So if you were to graph this, you would take your -8, -1, 0, 1, 8. You would add 2 to your x's, and you'd multiply the y's by -5.